The topic today is intensity. What is intensity? Intensity in Urdu is shiddat. For example, गर्मी की शिद्दत समर में, गर्मियों में ज़्यादा होती है और सर्दियों में धूप या गर्मी की शिद्दत कम होती है. Intensity of sun in the summer season is greater and intensity of sun in the winter season is less. Now we come towards the technical definition of intensity. What is intensity? Define it. So, intensity is sound energy per unit time passing through area which is held perpendicular in the path of the sound waves. You may copy this definition or you may just tell in an easy way. I will tell you by writing it in this way. What is intensity? Here, intensity is sound energy per unit time per unit area, and area is held perpendicular in the path of the sound waves. Here, suppose these are the sound waves coming. Here is a area which is held perpendicular in the path of the sound waves. You see here, it is held perpendicular, means making an angle of 90 degree with these sound waves. This is area, and you will see for how much seconds it passes through this area. 2 seconds, 3 seconds, in 10 seconds. Anyhow, it will take time to pass through this area. So, this is the definition. Energy, sound energy, it is sound energy. Per unit time, for how much time it passes. Per unit area. In what area it is passing. And the area must be held perpendicular in the path of the sound waves. So this was the definition. This is the easiest way to learn the definition. Sound intensity is the sound energy per unit time per unit area. Now we come towards its unit. What is its unit? For its unit, again we will use the same formula and we will write unit of energy is joule per unit of time is second and unit of area is meter square. Now here this joule per second is watt and this per meter square can be written as meter power minus 2. So unit of intensity is watt per meter square. This is the complete definition of intensity. You define intensity, okay? You tell how these things are assembled and then you will describe the unit of intensity. That's right. Now we will study the sound intensity level. In it, the point number 1 is the human ear responds to intensities ranging from 10 raised power minus 12 watt per meter square to more than 1 watt per meter square. It means we have sound intensities starting from I naught is equal to 10 raised power minus 12 watt per meter square. It is faintest intensity. Say reference intensity. It is reference intensity, and it increases and can become, say, I may become equal to 10 is power 0 watt per meter square, and this we know that is equal to 10 is power 0 means 1 watt per meter square. It is the level after which pain starts. After, you may symbolize it as IP, the instant intensity level after which, after pain may start in human ear. And then it further increases and it reaches up to, say, 10 is power 3 watt per meter square, and this intensity is of jet plane, intensity of nearby jet plane. So these are different intensities. Okay, this range is very wide, so that's why we use log to shorten this range. In formulas, we will not just use I as intensity, we will use log of intensity. Here you see it is written loudness is directly proportional to log of intensity. So we know if energy is greater, say if energy is greater, then it means intensity is greater, and if intensity is greater, it means loudness is greater. And as intensity has very wide range, therefore we shorten it using log along with intensity. So loudness is directly proportional to log of I, or we can write loudness is equal to some constant multiplied by log of I. It is equation 1. Similarly, loudness of the sound having the faintest intensity, we can write L naught is equal to K into log of I naught. This is for the faintest, this relation is for the faintest sound, and this is for some particular sound. And now we want to measure the sound level from faintest up to some particular level. We will subtract it. So we get L minus L naught is equal to K log of I minus K log of I naught. K is common, so we write K into log of I minus log of I naught. Now using law of log over here, we can write it as log of I divided by I naught. And this sound level, this is known as sound level, from faintest up to certain level of sound, and it is always in bell. Bell is unit of sound. When you increase the volume in radio or TV, it means you are increasing the sound level in decibel, because bell is very big unit of sound, so we use its smaller units. Similarly, as meter is very big unit, and you cannot draw something in meters on a page. When you are trying to drawing something on page, you use smaller unit of meter, and that is centimeter. You draw geometrical figures in centimeters on some page. Similarly, we will use smaller unit of bell, and that is decibel. How we will make decibel? It is in this formula. We will write k into log I by I naught. We will multiply and divide by 10, and this is in bell. You see, when in some equation sound level, when in some equation we multiply and divide with same thing, then there is no disturbance created in the equation. Now what we do is, here we will put the value of k is found equal to 1 experimentally. That experiment is not included in your syllabus. So putting the value of k as 10, and this is log I by I naught. You take this 10 in the beginning here, and this 1 by 10 of a bell. 1 by 10 mean 1 by 100 means centi, 1 by 10 means deci. So you write it decibel. So now you have a formula L minus L naught. You may write sound level or L minus L naught, but you had to prove this formula. That's why we are writing L minus L naught is equal to 10 times log of I by I naught taken in decibel. This is the unit, decibel unit. So this is the general formula we will use in numericals. So topic ends over here. What you will do is, first of all, you will give definition of intensity, then you will tell about unit of intensity, and afterwards you will tell sound intensity level. What are the sound intensity levels to which human ear responds? And these starts from 10 raised power minus 12 and comes up to 1, as I briefed over here. These starts from 10 raised power minus 12 watt per meter square. Okay, faintest intensity. It increases and it reaches up to level IP is equal to 10 raised power 0 watt per meter square, or 10 raised power 0 means 1 watt per meter square. And after this intensity level, pain may start in human ear. And for example, if a fast moving jet plane is nearby somewhere, you have gone to watch it, then its intensity level is given as 10 raised power 3 watt per meter square, means 1000 watt per meter square. And as it is after the 1 watt per meter square intensity level, so you may feel a kind of pain in your ear. And after it, how will you explain it? You will explain it by giving a derivation of formula L minus L naught is equal to 10 log I by I naught. And for it, you will write, we know that loudness is directly proportional to intensity, because if intensity is greater, it means energy is greater, and if energy is greater, then it means amplitude of the vibration of the vibrating body will be greater, and that's why loudness will be greater. You have not to mention all these things over here, but you must know that loudness is directly proportional to intensity. And as range of intensity is very wide, so to shorten that range we use log with the intensity, and we write loudness is directly proportional to log of I, or L is equal to some constant is multiplied k log of I. This is equation 1. And here for the faintest sound, L naught is equal to k log I naught, similarly as equation 1 is formed. This is equation 2. Now subtract both these and we get the difference of the sound level from the faintest to the particular level of sound. L minus L naught is equal to k log I minus k log I naught, k common, and log I minus log I naught can be written as log I by I naught, as we are taught in mathematics. This is law of log. Log A minus log B is equal to log A divided by B. And this sound level is given in bell. And as it is very big unit, so we will shorten it. How? We will multiply by 10 and divide by 10, so that this equation is not disturbed. We will use the value of k as 1, calculated in the higher classes, and we get L minus L naught is equal to 10 is brought here in the beginning, and we got 10 into 1 into log I by I naught, and this 1 by 10 means deci, 1 by 100 means centi, 1 by million means micro, 1 by 10 means deci. So we write it decibel. And thus we proved the formula L minus L naught is the sound level of particular sound, and which is equal to 10 log I by I naught, and unit is decibel. And this formula will be used to solve the numericals. Thank you very much.